Hey everybody, this is Alex Merced, and you're listening to my tech podcast where I talk about tech things that I want to talk about. And honestly, the thing that's been on my mind is just really kind of getting my hands around what's possible with AI. And then just kind of seeing like how far I can push it and what tools are available. In the last podcast, I talked about how I've been really exploring like the Google set of tools. And I've still been doing that. I've been having a lot of fun with Notebook LM and Gemini and Anti-Gravity. And the more that I play with it, the more I really enjoy it. So since like the last time I talked about how I was making a data lakehouse catalog called Pangolin. And this is literally just like I did it solo with Google Anti-Gravity. And it was a really good experience. And just to kind of reflect on sort of like the difference in experience, like I've used other sort of in-agent experiences in, let's say, like VS Code or Claude Code. Now, I like Claude Code quite a bit. Like, Claude Code is nice, but you're using it from the CLI. And, again, long as it can read your entire repo. Then there's, like, a lot of times, like, the browser agents, or not the browser agents, but, like, the IDE agents that are built in, like, VS Code, where oftentimes you kind of have to kind of tell them which files to focus on when you're giving them prompts. This is why I like Anti-Gravity. Like, Anti-Gravity kind of mixes, like, the experience of both of those, where like I'm not having to be as I'm not having to like drag and say, hey, these are the files you should need to focus on. But it seems to have like understanding of sort of like the full repo, or it does a good job of like looking through the repo to kind of get the context it needs to do work. So as the repo gets larger, it still works. Now, again, there are sort of like the specific features of Anti-Gravity that are particularly cool. So again, the things that are sort of unique to Anti-Gravity as an IDE are one, the subagents, where you can actually have like subagents that are sort of like doing work, but more particularly like the browser agent, where it can actually commandeer Google Chrome and actually like test websites and visuals out for you, which is okay. Like it can do a lot of stuff. Like I when I was building Pangolin and building specifically the UI, I did have it test some things, but it's not perfect. Like it doesn't have eyes, so oftentimes cannot detect certain like perfect spacing issues or color issues or whatnot. More so, it when basically there's just sometimes things that just didn't work, but they didn't necessarily fire off errors. Like maybe it was like a button that wasn't wired, um, an API call that was successful, but it didn't return what it was supposed to return. Things like that, it just didn't catch, which is understandable when you really kind of think about how it works. So it's particularly with the UI, I had to do a lot of manual testing, which I'm not complaining about. Considering like I built the whole catalog software by myself, with all sorts of different performance enhancements, supporting all sorts of different backends, supporting credential vending across different clouds. Like this is things that like for other catalogs took years to implement. To be able to get that all functioning in such a basically a couple weeks was, very eye opening. Again, it's not something I think just anyone can do, because again, I was specifically able to build that because I really, really, really have an deep understanding of like how specifically Lakehouse catalogs work. And to move the point, what I did is I tried to build a gaming engine. I tried to sit there and say, hey, like, you know what? I'm still thinking about learning like Godot, or the Godot gaming engine, to build. Like, I've been getting really into like Metroidvanias, these sort of like games like Hollow Knight, Silksong, Constance, Celeste. I've been playing a lot of those, and I could make something like that with something like Godot, and Godot is actually a pretty good choice for something like that. But there's still a lot of things you got to build manually because it's not built specifically for that genre. Like Godot is a very general sort of like gaming engine, kind of like Unity or Unreal Engine, where you're gonna have to build out a lot of the mechanics for your specific genre. Although it makes it a lot easier, like it gives you a lot of the basic shells. And then there's like genre specific engines like RPG Maker, Pixel Maker, things like that, where basically they kind of put you into they pigeonhole you into a specific genre, but it's going to be much easier because a lot of the things that you have to build out, a lot of the primitives you build out for that genre are kind of already built in. So then you're just focusing on building up the content and special features for your particular game. And I used to love RPG Maker as a kid. Arguably, probably what really kind of got me into the software development world initially. Building RPG Maker 2000 games back in like 1999, 2000, back in high school days. Time flies, especially thinking that I'm like 40 now. Okay, so I started like, well, I'm thinking about learning Godot. So I was like, okay, wait a second. What if I could just build a Metroidvania engine so I can just start with that and build, have something that's more purpose built for the genre that I want to build. That way, I still have to build the game, still have to develop the art, do all this kind of like work that I don't necessarily trust the AI to do well yet. And I tried to build that, but the problem is I don't know how game engines fundamentally work. So while I was able to like have it write a lot of code, I had no idea whether it worked. It did build an engine to my spec. It did build an engine that accepted like JavaScript as the scripting language for like events and things like that, and was built with Rust and was able to generate image through a screen. Like it was able to do fundamentally what I think an engine, the game, and a gaming engine does. But like the little demo that I made like was not a good experience. Where in the sense that we're like whatever like this little white square that was meant to be like the player character was controllable through like my arrows on my keyboard, but it would just like fall through the bottom of the screen. And again, because I don't fundamentally like know that type of software very well, I didn't really have a good idea of sort of like what am I supposed to be asking? What am I supposed to be testing? How do I know that this actually does what it's supposed to do? And at a point, I kind of got like so far down the rabbit hole where like, okay, hey, it was time to build the UI, but I wasn't confident enough that the foundation was good enough to kind of continue. I was like, okay, got it. This kind of proves the point that you really kind of need to know what you're building to build it. Like again, with the Lakehouse catalog, I knew exactly how I would want that to work. I know exactly what theoretically the code should look like, the mechanics of what it should be doing. How things kind of fit together, what are the interfaces, what are the APIs I'm working with, what are the gotchas, what are the like I'm it's something that I'm very intimately knowledgeable on at a high level and deeper than a high level, that I was able to implement that very easily, very quickly, and very robustly. Okay, so and same thing with like some of the other things I implemented, like the libraries I built for Dremio, like Dremio Frame, the Dremio CLI, and Dremio Simple Query. They're things that I knew what I was trying to build. I knew what I was trying to build was working. On Dremio Simple Query, I originally built manually. Like I wrote that a few years ago. I did enhance it during this sort of with Anitgravity to upgrade it for certain, like just make it more robust for certain edge cases. But fundamentally, it does the same thing. But then I did build Dremio Frame and the Dremio CLI completely with Anitgravity. And again, I know the Dremio API. I know where the docs are. I was able to kind of give it enough context. And I knew exactly how it should be tested and what those tests should look like. That I was able to build something that works pretty solid, pretty quick. Okay? So moral of the story is Anitgravity definitely, to me, feels like a step up in being able to kind of like autonomously build software. But you still need to fundamentally know what you're building and how it should be built to build it. Okay, I don't have to necessarily write the code as much myself, but if I don't know what tests should be, what the test results should be, because another thing is to tell it just like, hey, write some tests. It'll write tests at a pass, but is it testing the right things? Is it fundamentally doing what you want it to do? Okay, so there is still like that engineering mindset and that product mindset. You need to kind of have both at the same time is because you need to make sure that, hey, what you're building is usable. Like what is it that you're building? And then two, sort of like the engineering questions about sort of how it's fundamentally put together and how does that look like when it's right. You need to have that mindset. You need to have that knowledge. And this puts me, this is sort of raises an interesting question. So for those who've been doing software development before sort of this era of AI, this is going to be awesome. Okay, this is going to make life really much easier, increase productivity. You're going to start seeing sort of such a rush of innovation. For those entering the field right now, it's going to be very frustrating because that engineering and that product mindset is really hard to develop if you don't have ever build software, like if you don't ever write code yourself. But you'll never be able to build things as fast or as robust manually, very quickly, like in the sense like it'll be much harder to build up that knowledge because you'll never be working in that situation like in the past where you'd work in these teams having to coordinate with each other, having to kind of figure out what the right tests are. Like, there's all these sort of situations and frictions that you would run into that gave you the intuition and wisdom that is going to allow you to really leverage AI very effectively. Now, how does a new person build that? when you're not necessarily going to experience the same thing anymore. Now, basically, that means a couple things are going to happen. Because, I mean, this is the same thing with any kind of innovation in labor when you really think about it. Like, something makes life easier. People who did it the hard way are really going to be able to take advantage of that new way. And then there's going to be this weird transition period where it's good enough to make the old crowd more productive, but it's not good enough that someone with zero experience can really use it effectively. And then that's going to be sort of where the innovation comes in. Like, basically, now it comes down to sort of how do you robustly build safeguards where basically some of those that wisdom isn't necessary anymore. That wisdom that is no longer attainable, that intuition that is no longer attainable, is no longer needed. So that way people can focus on building the new levels of wisdom and intuition that are going to be needed as sort of like you shift over. And again, there's going to be a transition period because you're going to start having like new developers kind of come in who don't have sort of that precursor knowledge or experience. And they're going to have to learn the hard way. Like, it's going to be just, they're going to struggle with the AI because they're not going to have that experience of sort of manual world, and then they're going to fill in the gaps because they're going to know what those gaps are better. For example, someone like myself, I wouldn't say I'm like a 20-year veteran in development, but I understand, I've been around long enough that I understand it very well, that a lot of those gaps, I don't naturally think, oh, they're gaps. They're just things that are like, oh, okay, well, this is how I would have done this before. Let me just tell the AI to do it the way I would normally do it. And I am very productive with it. Again, someone who's new development's not. They're going to see those gaps much more clearly and going to know, hey, working with someone else, they're going to develop innovations that'll help continue filling those gaps. As we were already saying, again, if you think about like from the early days of like Microsoft Copilot just doing tab autocomplete to now like Anitgravity pretty much autonomously writing entire bits of robust software. Not like, we're not talking about small to-do list applications. We're talking about enterprise grade lakehouse catalogs in this example. But it's going to be pretty interesting to kind of see how this evolves. Like, it's already kind of evolving. People, for example, like I am kind of technically still using what I'm trying to learn is sort of like the old way of handling a lot of this stuff, of using a lot of markdown files and using sort of like bespoke markdown files to track state, track planning, things like that. Now there's sort of all sorts of new innovations. Like I was reading about something called beads, which is, I think, is like BD, beads. And what it is that it essentially, I think it builds like a local SQLite database that tracks state and tracks sort of like history and outstanding issues and things like that, to better maintain memory as it goes, and sort of what tasks are complete and things like that. So that way you don't have to be just keep saying, hey, go look at this markdown. Make sure you double check this markdown. Because that's the way, and that's probably still the way I will be doing it for at least the short run, where I have a markdown with my plan, and then between tasks, I'm constantly telling it, hey, go read the plan again, update it for the things you've completed, take a look at what's outstanding, make a plan for what's outstanding, come back to me with sort of the implementation plan. Let me take a look at that implementation plan, which is another cool feature of Google Anitgravity, where you can actually annotate the plan. So basically, you don't have to sit there and say, hey, make these adjustments to the plan, which is what I've been doing. But actually built in, you can read the plan and write annotations in the plan called artifacts that provide additional context. And now that plan is going to keep referring back to. Okay, which is different than necessarily the markdown that I'll have it manifest. So like I'll generally have it take its plans and write it again into a markdown file, just in case I start a new chat and I want to refer to it. But because one thing, Anitgravity again being new, it is buggy. So generally what happens is, like, once a chat's been going on for a while, there's a certain point where it feels like it gets to a certain size that it just starts crashing. So in that case, I tried to make sure that I always have sort of where I am at this point ready for a fresh chat summarized somewhere. But yeah, no, that was all really, really, really cool. Now, again, I was mentioning beads or stuff like that. Also, there was some new model coming out of China that was like released like January 1st, so like yesterday. That's really interesting in the way they've trained it for like software development, where generally what happens is that people train models on finished code. So it knows what the end product should look like, but doesn't necessarily know how to iteratively develop. Like how should like MVP in the different stages, and how to sort of traditionally iteratively develop software in sort of the right way. So like if you take a look at my pangolin commits, you'll see like there's just these large commits with lots of code implementing like entire features. Not the way it would necessarily work. You know, you'd create a branch, you would create a few maybe interfaces first, commit that, push that in there. Hey, I have the interface now. Then let's say we're talking about the backend in the backend stores for Pangolin catalog. First maybe I'd create the Rust trait, essentially the interface for those who parlay Java, and then I would then go create the in-memory implementation, and each of these would be like a separate branch, a separate PR. And you would iteratively build this. First, I would build the in-memory implementation of the trait, then the SQLite implementation of the trait, then the Postgres, Mongo implementations of these traits one by one, write a bunch of tests. And I did try to take that approach. Again, I would try to every time we made an update to the trait, I would go through each backend. First, I would have it do it within memory, make tests, write regression tests, make sure that they don't break it later. Then I would do the same thing with SQLite, so that way it would kind of learn from each iteration. But it didn't kind of like naturally think that way. This new model, what it is, it's trained on not just the finished code, but all the commits in between, so it can see how the code evolves. So it has an intuition of sort of how you're supposed to appropriately like sort of develop, and sort of what those development practices are. So it's actually scoring really well on benchmarks for coding. Okay, I don't remember what the name of the model is, and I don't necessarily think a lot of these like open weight models are going to like take over the world, because it's just not as convenient to use them as, let's say, hey, I can just open up Anitgravity, I have my Google account, and then I have the models that I can choose from there. But I do assume that as companies like OpenAI, Anthropic, Google continue developing their models, they're going to learn from some of these techniques, which they've already had been from a lot of these open weight models. These open models, especially the ones like coming out of China, because they've been releasing a lot of these open weight models. Okay, and then like everyone was like, oh look, it's open weight, which just means like, hey, and well, actually let me talk about what that means. What that means is, like, in the sense, when you think about open code, you think about open source, and meaning I can actually read the code. But the way an LLM or a large language model works, it's all about how it weights all the parameters, okay, all the features. So basically, all of these models, they work by taking information you put into it, inputs, and then turning it into vectors, so a bunch of sequence of numbers. And the idea is that you have this infinite, or very large dimensional space. Okay, so we think in the world of like 2D, 3D, with you think about, hey, there's these dimensions, and I can, if you think of a map, a 2D map, you can think, hey, I have coordinates, and I can determine how close Alaska is to Saskatchewan by knowing the coordinates of those two locations, and using your eyes, you can do like a search saying, hey, these things are like similar to each other, or they're close to each other. Now, essentially, the way NLM works is that it's generating all this data into all these numbers, each of them representing a different dimension, which can be like billions of dimensions. Okay, so when you hear like these like 1 billion parameters, those are like the number of dimensions that it has. And basically, based on sort of where that is in this sort of finite dimensional space, it can determine, hey, is it close to these other things to kind of determine, hey, what is sort of related, what is the response, based on sort of like these numbers, and then every model is going to have certain factors that it takes. So it's going to take those tokens, weigh them in different ways, so those are the different parameters or features, and then weigh how significant each of those parameters are differently. So that's why you hear the term open weights, because one thing is to have an open model in the sense where I can download the model and deploy it myself, but then what happens is that I cannot tweak the model or replicate the model if I don't know what the parameters are and how they're weighted. Okay, so when you hear open weight, it just means, hey, not only can you freely download the model, like there's other models that have been created by other entities that are open in the sense that, hey, you can freely download them. The only way to use them is not through some sort of service or hosted, but these open weight models, they actually have like, hey, here's the parameters, here's each weight is parameter, so you could theoretically recreate and tweak the model to enhance it even further yourself if you'd like to. Now, I don't know what the commercial licensing is, in the sense that, like, hey, just because it's open weight, does that mean it's, free for other people to commercially build on? That's a different question. Again, there's all sorts of different elements to licensing and openness. It's something I've really learned to appreciate the last few years, spending a lot of time talking about open source and delving into the open source community and all that fun stuff. So, but yeah, 2026 is going to be an interesting year, because when I'm sitting here like just playing like with like what you can do now software development wise with things like Anitgravity, and again, people have gotten really productive with tools like Cloud Code or Cursor and whatnot. Everyone's kind of developed their flow. Okay, I find Antigravity's flow very, very intuitive for myself, and very, very easy. But again, you're going to start seeing the same ideas being implemented into Cursor, into Comet, into all these other sort of, forks of Visual Studio Code and Visual Studio Code itself. And you're going to see the pace of innovation really increase this year. Like, just literally like, okay, hey, if you have an idea, you can just make it happen. Again, assuming you have an understanding of what you're trying to achieve, not just the idea, but the layers in between. Years of sort of like, software development finesse is becoming less and less of a barrier. And also just having the time to code. Like, that's honestly like all the stuff that I built over the holiday, I could build. Like, I have the knowledge to manually code it. Now, would have I coded it as well as the AI did? Probably not. And be able to also build documentation and a robust testing suite and all these things? Probably not. Okay, there would have not even very few tests, some documentation. You can AI generate documentation even beforehand, and that definitely accelerates things, but not in the same way I did with this. I was able, at the same pace I was able to do with Anitgravity. So, again, time was always a big bucket. I had all these ideas and things that I thought I would really like to see as a reality, but time was the issue. And Anitgravity really, and then again, just this world of AI coding really, really changed that. And I think that's like the dynamic. Again, it's still not a point where I think anyone without a good amount of experience and high level understanding of the space can build a thing effectively. Like, you could build a website. Like, honestly, like nowadays, if you wanted to build your own like personal website that looks really pretty, you can do that. And I made a video where I walked through someone who, hey, if you want to build your portfolio website in like a few clicks, really nice and pretty, it's super easy. Like, I took Anitgravity, went to all my old websites that I built, improved their SEO, added new levels of functionality. And that doesn't really require much knowledge at all. I mean, you do need to know how to deploy and things like that, but even that's pretty easy these days. But again, when you start talking about like bigger pieces of software, like in this case, talking about like a Lakehouse catalog, which is a much more complex piece of software, or a video game engine, being able to like do a good chunk of that and get really far with that with AI nowadays is a lot more practical than I imagined it would have been this time last year. So yeah, that's just food for thought. Hopefully you guys found this interesting. Again, this year, like every year, I will be going out there and presenting and talking and whatnot. So if you want to follow what I'm doing, make sure to subscribe to the podcast. Make sure to head over to alexmerced.com to make sure you're like subscribing to my Substack and following me on LinkedIn, so that way you don't miss wherever I'm at and what I'm doing. And yeah, we're kicking off 2026. I think I threw in a few many 20s there, but let's have a great year and enjoy.